Hello everyone, welcome to the presentation on Microgrid on blockchain, how to power your household on demand with IoT, blockchain, Fiori and S for HANA. My name is Ashna Lal and I am here today with, is it not on YouTube?
It's on, it's on. It's on, you can go on.
It's all good.
My name is Ashna Lal and I'm here together with Prabhat Patania and Bart van de Kamp. On the agenda for today, there is information about blockchain technology, microgrid on blockchain, its architecture, as well as SAP Hyperledger Fabric. So what exactly is blockchain technology? It's a distributed ledger of transactions within a peer-to-peer network, which is copied and sent to all. Here, transactions can be anything digital, such as digital media, digital documents, or digital currencies. It has decentralized power of control, which determines the existence, the nature, and the evolution of the ledger. And it is secure through cryptography on several layers within the network, which makes it immutable, which means anything that has been added to this ledger cannot be changed. Algorithms within this network secure against faulty nodes, against crashes, and against hacks. So what this brings is great transparency, efficiency, as well as security and trust. Because without everyone in the network, you cannot change anything in the transactions. So blockchain technology, if we would look at it from 100% centralized towards 100% decentralized, where the traditional typical systems, such as the ERP systems are on the fully 100% centralized. And where blockchain is, such as Bitcoin, the fully public blockchain, is 100% decentralized. So this is permissionless. There's no permission needed to be part of this blockchain. It's public and it's fully shared. However, there are two other options of blockchains. So this is a consortium and a private blockchain. The consortium blockchain is permissioned, it's public and shared. However, you can give permissions as to who can be in this network and who cannot. And the private blockchain is permissioned, it is private, and it's shared. So the difference here is in the public and the private. SAP has also jumped onto the bandwagon of blockchain because part of its SAP Intelligent Technologies is blockchain as well. So this is what we will be looking into today. SAP blockchain is divided into two parts. It's SAP Cloud Platform blockchain and SAP HANA blockchain. Part of SAP Cloud Platform blockchain are three platforms. Firstly, Hyperledger Fabric, Quorum, as well as multi-chain. What SAP HANA blockchain does, it is translating the data of the blockchain into the HANA business data, or translating the HANA business data into the blockchain. So this is a bridge of your HANA on-premise or on cloud database towards your SAP Cloud Platform blockchain. So let's have a look into the different platforms. SAP Hyperledger Fabric is a private permissioned network There are a wide use cases in multiple industries that this can be applied to. Its key properties are that privacy is on a need-to-know basis through channel creation, such as if you would create a Hyperledger Fabric network between 3 companies, you can create channels, for example, between company A and C, and company B would not be able to see the data. Another property is that there's a lot of co-innovation in this, as it's part of the Hyperledger umbrella. Others are, for example, Hyperledger Sawtooth. And one of the key properties that makes Hyperledger Fabric especially different is that it has a modular design. So it has plug-in components. For example, you can choose what kind of algorithms you would like to use in this network, or what kind of voting systems. For Quorum, it is for private permission networks. However, this is especially for financial transactions. Its key properties are its maturity, because Quorum inherits Ethereum's key properties. So it has gone through a lot of versions, and which can make a bit more sure that it has greater maturity. Also, privacy and transparency, it is customizable. And Quorum has a zero-knowledge security layer, which means that private settlement can be done without compromising the private data. And then looking into multi-chain, this is for private blockchain networks, for example, especially for the institutional financial sector. Its key properties are that it's private, so the visibility is only for chosen participants. It is permission because of the handshaking process. The handshaking process means that if you would like to be part of this network, that someone has to let you in, and there has to be some sort of agreement. And also it is privileged. So mining is secured through privileged voting. Now let's have a look into SAP Hyperledger Fabric blockchain in action. For this, we're going to talk about the developments in the energy market. As everyone knows, we are going from fossil fuels and gas cars, gas vehicles, towards, for example, solar panels and windmills, as well as electricity vehicles. However, this also brings the challenge of how to balance the supply and demand, especially for the grid operator. So for this, there is a new development called microgrids.
One such opportunity is a distributed landscape, which decentralized energy production is being consumed locally and surplus is delivered back to the grid on dozens of locations. This new model also allows consumers to become prosumers, allowing households and businesses to share and sell their excess energy. One step further, and communities transform into connected microgrids, exchanging energy also between communities.
So to summarize, the energy marketplace of a microgrid is a local energy, makes it possible to have a local energy system. And the energy marketplace, what is powered by blockchain, is a local energy trading platform between consumers and prosumers. Prosumers here mean households that produce energy as well as consume energy. So this is one development that reduces the grid congestion problems. This also prevents associated high investment for the grid operator, as well as gives insights in the energy flows, which brings predictability. And for the consumers and prosumers, there's a price incentive, so they have the opportunity to save money. Now, for this, we have used Hyperledger Fabric. The billing is done with SAP ERP, And as told before, there's a wide range of use cases that could be applied here. The data is on a need-to-know basis, and one main thing is that the matches within this platform are enforced by the Hyperledger Fabric smart contracts. Smart contracts are self-executing contracts of which the terms of agreement between parties is directly written into the lines of code, and these exist across the blockchain network. So let's have a look into the marketplace. What exactly does this look like? This platform firstly creates a profile. So here you see the personal information as well as the asset data. An asset here means, for example, the solar panels of a household. The dashboard, the personal dashboard, looks like this. Here you see the live feed, and here you can see the bid types. So here I would be selling energy. You see how much as well as the price. You see till when this sale is valid, and from and until when this energy will be supplied. If we look further, you also can see the historical data. So here you don't see only the sales bids, but also whenever the matching is created. So the status here, for example, for the sales, here you see as completed. It can also be expired whenever a match is not made. And you also see it as agreement when the match has been made. So the difference between completed and agreement is that whenever a match is made, the status is shown as agreement, and whenever the energy has been supplied, it will then go into completed. So looking further, you also have a community dashboard. So you also see the live feed of this. And one interesting thing here is that you also see the purchase order. So whenever you buy energy. And of course, you also have a market view of what you see here, the last 12 months. So here also you see the purchase orders whenever the matching is made, as well as the status of this. And now we will have a look into the architecture.
I'm audible, right?
Yeah.
Yes, we can hear you fine.
Good. So let's deep dive into the solution. So first, let's just discuss the architecture. Let's start from the left. So on the left side, we have consumers and prosumers. So consumer, as Ashna explained, is just consuming energy, and a prosumer can also generate energy. Consuming means it will, if it needs to consume energy, it will create a purchase order. If it needs to sell energy, generating energy, then it will create a sales order. Those sales orders and purchase orders are not exactly the same as within SAP. You know, the ME21N, VA01 transactions, but these are just transactions in the blockchain. So what will happen? We will have a deep dive in the IoT part a bit later, but it will send a request, a transaction into the blockchain via Java in the middle. The blockchain is basically the place where all the magic happens, and the blockchain will be explained by Prabhat. So the self-executing contracts, all the matching. And then on the right side, we have the S4HANA. S4HANA is purely used for billing. And on the top, we have the SAP Cloud Platform. So the Fiori dashboard is developed here. Also to emphasize, the main focus for this POC was the Hyperledger Fabric. So we also only have the licenses for basically the Hyperledger, and we try to solve the IoT component, for example, without the SAP IoT services, which was also perfectly suitable with small code, more simplified code. So if you look at the IoT, so what has been done, we basically took a power bank and we took it apart. So we have then the solar panel and we have a USB hub. So we can basically simulate that we generate energy and that we produce energy and consume energy. But to measure this, we needed a sensor. So we used the INA219 sensor, and this sensor is being able to measure the current. And current is known as the flow of energy. So there is one sensor between the solar panel and the battery, and one sensor between the USB hub as well. So we can basically measure generated and produced energy. On top of that, we use the Raspberry Pi Zero. Initially, I used the more advanced Raspberry Pis, but we are only running 2 scripts. So we are only running a script with Python developed to get all the data. I will show it how it looks like, and also to trigger the transaction into the blockchain. So it has a little bit of simulated mocked logic to predict if it needs to sell or buy energy. So how did it look like in the POC? Exactly like this. So we have this house holding here within the house. We have the USB, the solar panel, the power bank with the sensors. We have simulated a smart meter, so the local server. That's how we call it. And then we have the solar panel. So this is basically interacting with the blockchain, and it is really a working end-to-end solution from the IoT completely into the blockchain. For the demo part, I have put this whole thing back in my garden. To avoid technical issues, I'm not going to do it completely live, so I don't have the video streaming at the moment. So I just took a picture. In the Netherlands now the sun is rising, so it's getting warmer and warmer. So this was a screenshot from the morning. So this is one Python script, getting the actual measurements. And if I show it right now, then you can already see these are another 2 households, and the generated energy is much higher at the moment because the sun is rising, right? If I go back to the presentation. So you have seen script 1 to get all the generated and produced energy. And there is the second script, which is doing the calculation. So all the data is being sent into Redis stream. And then there is some script taking a look at the last 50 minutes because it's just a POC and it's mock logic. And then based on that, it will make a decision to either create a sales order or a purchase order in the blockchain. What you need to see here is 2 of these households created a purchase order, the 2 left ones, and the right one created a sales order. And if I take a better look at the middle one, you can see actually some data from the blockchain. So it has agreements as well. And all this has been done by the blockchain, which will be explained by Prabhat a bit later. So it's just sending purchase orders, sales orders from the IoT device via Java REST services into the blockchain. Blockchain is doing all the matching, and then we get back the agreements. Yeah. So Prabhat, can you take over the blockchain part?
Yeah, sure. Am I audible?
Yes.
Okay, thank you so much.
Thank you.
Okay, I hope my screen is visible now. Yeah, so first of all, let's start with the architecture slide that Bart just explained. So when the requests are sent to blockchain for creating an agreement between a sales order and the purchase order, for this purpose, we are using SAP Hyperledger Fabric. So let's take a quick look at the dashboard because this is where the whole blockchain architecture or the control lies. So we have different sections here: channel, explore, chain code, API calls, logs. We'll discuss these sections in a short while. I have a small recording of how the blocks actually look inside the. So here we see these are the different blocks that are inside the blockchain. And we see the data that is written here, the transaction that it holds. And the chain keeps refreshing each time a new block is added. We'll discuss different parts of it more in detail. but this is just an overview of how the dashboard looks like. And the values that are coming in inside the blockchain are captured here. So I'm highlighting here the type S, P, and A, which is for sales order, purchase order, or an agreement. So this is pretty much say what comes inside a block of a blockchain. So now let's take a more detailed look into these things. So on the dashboard, we have channel, explore, chain code, API calls, and logs. So a channel allows you to participate in a blockchain network. An organization can be part of multiple separate blockchain networks. So each channel links you to one of the networks. In the explore section, this is what we see right now. It gives an overview of all the blocks that are maintained inside the blockchain. A chain code is something which is also a replaceable term for smart contracts when it comes to Hyperledger. So in our case, we are using Hyperledger Fabric. So it is the smart contracts are also called as chain code. And then in the API calls and the logs, it's more for the monitoring. We can see which chain code was triggered at what time and all the logs that are maintained. Yeah. So now let's take a deeper look inside what comes in a block. So I'm pretty sure everyone would have heard of hashing algorithms or how everything is encrypted inside a blockchain. So each block has a hash that is generated. So we see here, so hash of the current data segment and previous one. So both are maintained here because that's how the chain is created in a blockchain. And then we have the chain code. This is something, this represents that which smart contract was executed to add this information inside the blockchain. And
Sorry
this,
for interrupting, but you guys have 2 minutes left.
okay. And then we have the function create purchase order, which represents that, okay, which operation was performed, and then the block was added in the blockchain. So let's take a quick look inside the code. So we need to maintain the name of the smart contract. This is something we saw already in our screen here. So we have blockchain energy market, and this is what we maintain here, and the version. This is the Swagger file. So we maintain which operation can be performed and also the definition, like the parameters that it can handle. And inside our code, we use Golang for maintaining the smart contract definition. So if we have a case of create purchase order, we maintain the code to how to create a purchase order. So here we use some kind of smart logic to say read the existing chain and see if someone is already ready to buy energy at a price at which this person is to sell. And then we do a get, say a read on the blockchain, try to match depending on the parameters of date and price, and also the act, like if the order is active or not. And using all this information, we try to create an agreement. So if we go back to our screenshots, so this is one of the examples of a block where an agreement was created. So we can see the type is A. It shows the sales order that was linked and the purchase order that was linked. So when an agreement is created, it basically means a trade is going to happen. There is going to be an exchange of energy. So it mentions the quantity that was involved, the currency, and also unit of measure, and also at what price this agreement was created on. So if I'm willing to sell, say, 50 units of energy and someone wants to buy 10, an agreement will be created for 10 units, and then my order will be updated that, okay, out of 50 now 10 is consumed. So now my order is updated with, say, 40 units are available now. So this is how our smart matching logic works. For this, we create a query in the system. I can maybe still have time to show this. Yeah. So here we create a query string, selecting, say, type is sales order. We use price as one of the parameters. Then the validity dates. Is it valid within the date range? Within the period, the status should be active. And we sort it by price. So it is also possible that if I want to buy 50 units and people are only ready to sell, say, 10 each. So then in that case, multiple agreements can be created. So I can have 5 agreements with 5 different people willing to sell 10 energy units. That is why we sorted with the price. So the first agreement will be created with someone who is willing to sell it at the lowest price. So because that is beneficial for me, it's in my interest. So first we create a string. It returns all the orders that are available for sale within this date range, and then it tries to consume all the quantity that is offered and create an agreement on top of it till my demand is fulfilled. So yeah, so this is something like how we write our smart contract logic here. Again, we have used Golang here. There are multiple languages available in which the chain code can be written. And yeah, so once we have this, okay, so how do we deploy this? When we have our smart contract ready, we can see here, we have the section for chain code. So when we go inside this section, there is an option to install a chain code. So when the chain code is added to the network, it is spread across all peers that are available on a blockchain network. And now it can be consumed with everyone. So anyone who wants to make a transaction, they can use this chain code. That's pretty much it from this side. Bart, you want to take over again?
I think we're running out of time due to technical issues. We started a bit late. Apologize for that. Yeah, so that's it, I think, for now.
No, guys, you have 7 minutes extra. So you can go on. You still have time.
Okay, let's use this time then for questions. Are there any questions in the YouTube channel?
There's no question yet. So if there's anyone want to ask the question, you can type them away on the live chat.
Or we can go in this Discord channel to discuss afterwards. Yeah.
Yeah, so we're running off time. So if you guys have any question, you can join the Discord channel and go to Unconference channel to have further discussion. So and we have some announcement to make. So
No, thanks all for listening, and yeah, good luck to the other speakers today. And thanks for organizing.
Congrats to Manat Singh for winning the prize, and that's all for today's session. Thank you.
Bye.
You can disconnect.